Now that we've covered the four basic operations, addition, subtraction, multiplication, and division, we need to talk about some properties. So these are, you can think of these as rules. You can think of these as rules. And in this video, we're going to cover three of these properties, three of these rules. The first one is called the commutative property. The second one is called the associative property. And the third one is called the distributive property. You don't need to memorize these. You just need to memorize how the rule works. You don't have to memorize the title. So the first thing we're going to jump into is the commutative property. A lot of these are going to be common sense, or they're going to be things that you remember from junior high or even elementary school, to be honest. So the first kind of example of how this works, or how this works in a nutshell. Imagine we have A plus B. Does it matter that A is to the left of B? Like when we think about this, do we have to say that it's A plus B and not B plus? No, they're the same thing. It doesn't matter if you were to do 2 plus 3 or 3 plus 2. The reason why this is important is because if you're adding or subtracting a bunch of things together, the order doesn't always matter, especially in addition. Actually, I take that back. It does matter in subtraction. We'll talk about that. But in addition, the order does not matter. If you're adding a bunch of elements together, feel free to mix them up. It's not going to change anything. Again, 10 plus 12 is the same thing as 12 plus 10. The same is true of division. If you are multiplying A times B, that's the same thing as multiplying B times A. Do you remember in the previous video, we talked about if you put two variables right next to each other like that, that means they're being multiplied together. So here's an example. 2 times 3 equals 3 times 2. We know that these both equal 6. And here, note, this does not work for subtraction or division. I said initially, I spoke off the cuff. I spoke incorrectly. This does not work for subtraction or division. And we can kind of create our own example to show why it doesn't work, right? So let's actually create our own example. So imagine we were to do, for example, 3 minus 2. Does that equal 2 minus 3? No, it does not. This is 1, this is -1. So cross out that bad boy, it doesn't work. Same thing with division. If we were to do 6 divided by 2, does that equal 2 divided by 6? No, this equals 3, and this equals 2 over 6. If we write it in fraction form, remember this fraction form really means division, is what it means. And of course, we can simplify that. We'll talk about that when we come to fractions. But of course, we can simplify that to 1/3. If you don't know how that works, how we simplified that, don't worry. We'll talk about that in fractions. All you need to know right now is you can't mix things up, mix up the order if we're talking about subtraction or division, but you can if we're talking about multiplication or division. So that's the commutative property. Let's zoom back out and go to number 2, which of course is the associative property. So what is the associative property? What is the associative property? So let's look at some examples. So if we're adding 3 elements together, A plus B in parentheses plus C equals A plus B plus C, where the B plus C is in parentheses. Now, when we get to talking about PEMDAS, which again is going to be in an upcoming video, that means the order that we do things in. And the P in PEMDAS stands for parentheses. Okay, if you guys are wondering how to spell PEMDAS, and don't worry, we're going to have an entire video devoted to it. So again, you don't really need to understand it fully right now. So PEMDAS. This basically is called the order of operations, the order we do things in. And the first thing is parentheses. But if we're adding these 3 elements together, remember, when you're adding things, the order doesn't matter. So I can first add A plus B together, or I could add B plus C together first, and you'll get the same result either way. If any of these are confusing to you, you can always create your own example. Don't forget, you can always create your own example. So for example, 3 plus 4 plus 2. If we were to do the 3 plus 4 first, we get 7 plus 2, which is 9. If you look on the right side, if we were to do 4 plus 2 first, that's 6, and add the 3, we also get 9. Oh, how cool is that? Now remember, addition and multiplication are kind of connected to each other in a lot of ways. So the commutative property worked for both addition and multiplication. The same is true for the associative property. This also works for multiplication. It doesn't matter if we multiply A and B first together or B and C first together, you're going to get the same result in both cases. So here's an example. 3 times 9 is going to be 27, and 27 times 5 is going to be 135. If you're wondering how I was able to do that in my head, all I did was, so you have 27 times 5. All I did first was think, oh, okay, 27 is 20 plus 7. So what is 20 times 5? That's 100. What is 5 times 7? That's 35. And you get 135. Is that the same thing as first multiplying 9 and 5 together? So we get 45 times 3, right? So again, let's think about this. 45 times 3. 45 plus 45 plus 45. That's what that equals, right? 45 plus 45 plus 45. Or it equals 3 added to itself 45 times, but I'm not insane, so I'm not going to do that. So 45 plus 45 is 90, plus another 45 is 135. So when it comes to addition and multiplication, again, the order doesn't matter, even if you have more than 2 elements. It could be 4 elements, could be 5 elements, could be 100 elements. Feel free to mix them up to your heart's content. But again, this does not work for subtraction or division. Feel free to create your own example to figure out why. For example, put 3 numbers together where you're subtracting them and see if you can mix up the order and see if it works. You'll find that it doesn't work. The last property we're going to talk about in this video is the distributive property. Distributive property. This is not a pronunciation class. All right, so here we go. So again, PEMDAS, we're going to talk about that later. PEMDAS tells us that we should do the parentheses first. But whenever we're multiplying, we can think about ourselves, we can think that we're distributing the A to both elements in the parentheses. So for example, we could do A times B, right? We first distribute the A to the B, and then we distribute the A to the C. And on the right-hand side, if you look over here, we get AB plus AC. Plus or minus depending on what you're using. So you can see this one actually works for subtraction. And we'll look at 2 examples. Okay, so let's look at these 2 examples. Let's do it with the parentheses first on the left-hand side. What is 3 plus 4? So 3 plus 4 is going to be 7. And then we're going to do 7 times 2, right? 7 times 2, which is 14. Do we get the same result on the right if we distribute the 2 first to the 3 and then to the 4? Let's take a look. So 2 times 3 is 6. 2 times 4 is 8. And what is 6 plus 8? It is 14. So yes, we get the same result. So with multiplication, you're allowed to distribute into these parentheses. Kind of cool, kind of nice. And it also works for minus as well, which is also kind of cool and kind of nice. So what we have is, let's first do it the right way, where we do parentheses first. What is 3 minus 4? That's going to be -1. What is 2 times -1? That's going to be -2. Let's see if it works. So let's get rid of everything. Let's first distribute the 2 into the 3. 2 times 3 is 6. Let's then distribute the 2 into the -4. Remember, 2 times -4 here. That's going to be -8 over here. And what is 6 plus -8 or 6 minus 8? There's 2 different ways to think about that. You'll get the same result. It's also -2. So the distributive property allows you to take a multiplying element outside of the parentheses and then to essentially distribute it to each element inside the parentheses. And a lot of times that's actually going to simplify the problem. If you're wondering why would we even want to do that, well, it simplifies the problem in a lot of cases. So let's just recap. The commutative property, what is that? It basically says the order of addition and multiplication with 2 elements doesn't matter. A plus B is the same as B plus A. A times B is the same as B times A. The associative property is kind of like the commutative property on steroids. Imagine you have 3 elements, 4 elements, and like one part is bracketed in parentheses, which means do it first. Doesn't matter. You can move the parentheses all around as long as we're talking about addition and multiplication. And then finally, distributive property is with multiplication. When you have something sitting outside of the parentheses, you can distribute that element to each element inside the parentheses, and you'll still get the same answer as you would if you were to do the calculation inside the parentheses first. The cool thing about the distributive property is it works both for addition and subtraction inside the parentheses. It doesn't matter. So that's arithmetic properties number 1, which of course means there must be an arithmetic properties number 2, and that is coming up next.